Welcome back to Principles of Engineering, and this is the continuation of the problem set 1.1.2, Simple Machines. We did all of our lever problems on the first set, so let's now move ahead and start working on our wheel problems here. So they're pretty straightforward. I started out with number 10, and I just drew this out, and this is really a pretty simple formula just to remind you of the relationship between the diameter of a circle and its circumference. So the question says that if you've got a linear, the question asks you, what is the linear distance traveled in one revolution of a 36 diameter wheel? Well, remember, by definition, that is the circumference of that wheel. And you can envision this and say that, well, if I took this as tread, quite literally, this was tread on a tire, and I cut this tread and then I peeled it off, you can see that that would roll out into a distance out here that's equivalent to my circumference if I just cut that open and sliced and laid it out. So just knowing that the circumference formula of a circle equals to pi d, or it equals to 2 pi r, either one, doesn't matter, but we're given that d equals to 36 inches, so then the circumference equals to 36 inches times 3.14. That's an approximation for pi, so don't go crazy on me. I'm not Mr. Pi Day. It ends up working out to be about 113.10, depending on how you round that. I wouldn't go past 2 decimal places on this, just because you're at 2 decimal places there. But that's number 10. Pretty straightforward, huh? So let's move on to number 11, a little bit trickier here. So what we have now is a wheel and an axle. And what they describe is an industrial shutoff valve, and it's designed to operate with 30 pounds of effort force on the handle. So up here at the top, I've got my handle drawn, and I try to give it a little bit of, you'd think I'd learn about putting that layer on. I've got a little bit of grippy material on that, so that's my handle right there. And then down below here is the shaft in the valve. And what it basically says is it tells me that this handle is designed to take 30 pounds of force. It tells me that my axle size is 0.75 radius, so I took it into the diameter of 1.5 because it really asks the next question, or a few questions down, it asks you the wheel diameter here in a second. So that's your drawing. Pretty straightforward. Question number 12, what they ask you to solve for here is the AMA. Well, that stays the same as it's always been. So what that is a relationship between my force resistive and my force of effort. So if I look at this, I can see that my force of effort is 30 pounds in the denominator. My force of resistance here is 200 pounds in the numerator. My units cancel out. I end up with a ratio of about 6.67, and it's 6.66666666, but 6.67, close enough for it. Now the next question, there's a little bit of a trick to this, but it says, hey, what is the minimum, or what is the required wheel diameter to overcome the resistive force? And we're going to talk about whether that's going to be a minimum or a maximum here in just a second. But a couple of different ways we can look at this. The easiest way for me to look at it is to say, hey, if I'm just about to overcome the force, then the reactionary, or the moment force on the wheel is opposed by the moment force on the shaft. So what I can say is my moment of my resistance equals to my moment of my force. Or I can come through and say that and I can either do it in moments and talk about in terms of radiuses, or I could do it in terms of just torques. Doesn't really matter, but I'm going to use diameters because it works out to be the same. Well, I'll tell you what, let's use radius, so it'll make it a little clearer. So my radius down here is 0.75 inches. So this is my radius of my resistance. My radius up at the top, I don't know. So looking at the two moments, what I can say is the force of the resistance times the distance of the resistance has got to equal to my force of my effort times the distance of the effort. So let's look back here, and in yellow, let's go pink. Let's see what we remember here, what we know. We know that my distance of resistance is 0.75. We know that my force of effort is 300, and my force of resistance is 200. So it looks pretty simple. Looks like we have enough information to solve it. So I'm going to go 0.75 inches. Distance resistance times my force resistance, 200 pounds, equals to my force of effort, 30 pounds, times my distance of effort. And I'll solve for my distance of effort. And I'll do that. I'm going to go ahead and cancel this out in yellow. So I'll put 30 pounds down here. These two cancel out. Got to put it over here. 30 pounds over here. Those two cancel out. My pounds do. And then what I'm left with is I'm left with 0.75 times 200 divided by 30. That is equal to my radius of my wheel. Okay, so let me real quick multiply that out. So I didn't have that one done before. So 0.75 times 200. Divide that out by 30. I'm not getting love here on my calculator. There we go. 0.75 times 200 divided by 30. And what I get is a radius of equal to 5 inches. So that's my radius. So to get my diameter, D equals to 2R. Therefore, 10 inches is my diameter. Now, as we talked about, is that going to be a minimum or a maximum? And think about that. I would need to overcome my resistive force to make that valve open and close, don't I? So looking at this, here's my resistive force with my effort force. So really, I want this to be, my effort force to be greater than or equal to. So what I really need this to be is greater than or equal to 10 inches. So that's a minimum value that needs to be. All right, super. That's number 13. And that was, I believe, the last of the wheel and axle problems. So we'll move on to pulley problems in our next recording. Thanks.